So here we're going to show you what happens if you cross a heterozygous individual and a homozygous recessive individual and want to try to figure out what the phenotype percentages and phenotype ratios might be. So we've already set up the cross. We have our heterozygous, two different alleles, compared to a homozygous recessive, which is two little alleles, two recessive alleles. And we're looking for the phenotype with earlobes, detached versus attached. If you don't remember what that looks like, here on the left, you have an earlobe that is attached, and on the right, you have one that is detached. So there's this little bit of space between your earlobe and the side of your head. So let's go back. So we're trying to find detached versus attached. So if you have the dominant allele, you are detached, and the recessive allele, it's attached. So if you're looking at the results of the Punnett square, you have two boxes where you have heterozygous individuals and they have the dominant allele. And then you have two boxes with homozygous recessive. So these are the recessive, they are attached, and these would be detached. So 2 out of 4 is not 75. Let's get that out of there. 2 out of 4 would be 50%. And then 2 out of 4 boxes for homozygous recessive, that would also be 50%. Now, what would the phenotype ratio be? So, what's detached versus attached? So, you would have 2 detached. You have 2 boxes with heterozygous and they have the dominant allele versus 2 attached earlobes because you have 2 with the homozygous recessive. So, that would be the phenotype ratio. Okay, so you could stop the video, move your percentages, type in your ratio, and you are all set with that piece. The next thing that you're going to do is click to the next set of slides, and you're going to do it yourself. So this slide has you crossing a heterozygous individual with a homozygous dominant individual. So you'll be responsible for moving the alleles for the genotype for mom and dad. What's the result? Genotypes versus percentages versus genotype ratios. And then the next slide, you're going to do the same thing for phenotype ratio. It's a different cross. Here we have heterozygous. Actually, it's the same heterozygous and a homozygous dominant. Okay, but you are going to be responsible for getting the results. The results for this slide are going to be the same as the slide prior because you're crossing the same genotypes together. So if you're not sure how to do either of them, make sure that you go back and watch the little videos and make sure that if that doesn't help, you're emailing your teachers for help and support. All right, good luck.